When we're talking about probability, we need to consider what are called events, and the event is a certain outcome that we're looking for. What's the likelihood that it's going to occur? We're going to jump into an example, and you'll see exactly what we're talking about when we talk about events. So we're looking at a deck of 52 playing cards, and we want to consider some different events that could be associated. There's multiple events that could be associated with the deck of playing cards. We're going to focus on 4 of them right here. The first thing we want to consider is part A, where it says the event that the card selected is a king of hearts. If you're not familiar with a deck of playing cards, I have provided you with the illustration here of every card that's in a deck. I've actually encountered situations where students had 0 clue about playing cards, so that's why I've included this diagram. Your first row are spades, second row are hearts, third row are clubs, and your fourth row are the diamonds. Part A, the event that the card selected is the king of hearts. There is only one king of heart in the entire deck of cards, so that event is just 1 out of the 52 possible cards. So we have, it's 1, and we're gonna refine our notation as we go, but right now it's just 1 out of 52. The second event that we're looking at, the event that the card selected is a king. Well, that's going to include all 4 kings in this deck of cards, and that's going to be 4 out of 52. And if you're wondering why I'm using the 52, that's because there are 52 cards in a deck. The event that the card selected is a heart. So what that will include is this entire row of 13 cards. So that's 13 out of 52. And then finally, we have the event that the card selected is a face card. So face cards would only include jacks, queen, kings, and aces. So that would include these 12 cards right here. There's 3 face cards per suit and 4 suits, so that's 12 out of 52. And that's just simply what we're talking about when we refer to an event. What's the event that we're looking for? So when we're determining the sample space in the event, the sample space is the collection of all possible outcomes for an experiment. The events would be a collection of the outcomes for the experiment. So that's a subset of that sample space. And we're gonna see this with notation, and hopefully it'll make sense. So if we put letters on the events that we just looked at in the first example, we'll call A the event that a card selected is the king of hearts. B will be the event that the card is a king. C is the event that the card is a heart. And then D would be the event that it's a face card. So we're going to use Venn diagrams, and I'm sure you guys have seen this before. But when we talk about Venn diagrams, we have the rectangle represents our entire sample space. And then the different circles, they represent certain events. When they overlap, it represents intersections of events. And so we'll see here in this first diagram that I'm going to label number 1 here, the whole sample space is included with the exception of everything that's in that circle E. So what we're looking at here are the blue regions that indicates the events occurring. So everything in blue is not in E, and I think you can see that from the diagram. For the second diagram, we have the events A and B, and where they overlap, what they share and have in common, that is the events A and B. In the third diagram, both A and B are shaded along with their overlap center, and that is what we would call an event OR. So it's event A or B. So either one of those events can happen, and again, when we see some examples, I believe that's going to make a little bit more sense. So again, we're going to refer back to our deck of playing cards, and we are looking at an experiment of randomly selecting one card from a deck of 52, and we have these events. We're going to have A is the king of hearts, B is a king, C is a heart, and D is a face card. So we've already investigated all the possible outcomes that we could have, and so using that information, we're going to determine the following events. So for Part A, it's not D. Event D is when the card is a face card. So now we're talking about when or if the selected card is not a face card. So what that would give us, we know there are 12 face cards. Let's label these up here. There is one King of Hearts. There are 4 kings. There are 13 hearts. And there are 12 face cards. And we have a total of 52 cards in a deck. That might help clarify what we're looking at here. So for part A being not D, what is the possible outcome or probability that the card we select is not a face card? Well, if 12 cards are face cards, that means that there are 40 that are not face cards. So that's 40 out of 52. There's 40 out of 52 cards that are not face cards. Part B, I jumped to the right instead of going down. Part B is B and C. So that's the event that the card is not only a king, but the card is also a heart. You may also notice that corresponds to event A as well. So this, you don't have to make note of this, but this is also the same as just saying event A. This is the probability the card is a king and the probability it is a heart. Well, there's only one possible card in the whole deck that is a king and a heart. For part C, it's the event that it's either B or C. So that's the event that the card is either a king or that the card is either a heart. And there are 16 possible outcomes in that scenario. We have 13 hearts and 4 kings. I know 13 plus 14, 13 plus 4 is equal to 17, and I just told you there are 16 possible outcomes. But what we have to remember is there is one card that has both properties. There is one card that is a king and also a heart. So it can only occur one time. So we actually end up with 16 out of 52. And then finally for part D, it's the events C and D. What's the event that the card selected is a heart and that it is a face card? So we have 13 hearts, but out of those 13 hearts, only 3 of them are face cards. So for it to be a heart and a face card, that's 3 out of the 52 possibilities of randomly selecting a card. Example 3, we're given a frequency distribution. And this shows the ages of 40 students. We have one student selected at random. Event A is that the student selected is under 21. Event B is that the student is over 30. Event C is that the student is in his or her 20s. And then event D is that the selected student is over 18. Part A, find the following. And you're looking at first, not D. So not D is, first of all, D is the event that the student is over 18. So not D would be a student is 18 or under. And that would only include these 2 rows right here. So we have 2 students that are 18 or under. That means they are not over 18. And the reason we include 18 is because this explicitly says over 18. So we have 2 students that are not over 18. Part B is A and D, that the selected student is under 21 and that student is over 18. So we're looking at any instance where the students are under 21 and over 18. And so that's going to include these 16 students who are 19 and 20 years old. Part C is A or D, and that would be the event that the selected student is under 21 or they are over 18. So that would be that would include all of the students that are 21 because they're over 18. And we're going to get Part C is that situation where we have the or. So there's going to be overlap, but in this case we're going to see how this works out. So first of all, the student is going to be under 21. We also have the event that the student is over 18, or they are both under 21 and over 18. So if we just focus on first the event that the student is over 18, that's going to include all of these students. The second part of this is that the student is under 21. So that would again include, I need to change my color somehow. These students are under 21. So what you notice is we've basically circled every student that could be possible in this group. And so that actually ends up being all 40 students selected, because every student in there is either over 18 or under 21, or is what makes the difference. The and is what they share in common. The or would be everybody that's under 21, or it could be everybody that's over 18. So even the students that are in their 30s would fall into that category of being over 18. For Part D, it's B or C, the event that the student is over 30 or they are in their 20s. So for that situation, we have they're either over 30, so let's highlight that first. They're over 30 would be 35, 26. We also have that this student is in their 20s, and that's going to comprise these students. So what we end up having is this entire group is part of the or scenario as well. If that were to and, it would be an empty set, because there are no students who are over or in their 30s and also simultaneously in their 20s. So that's where we would have an empty set. But in this case, because we're talking about or, it can be either situation is included. We have a total of 29 students. If we added all those values up, you can also just look. We have 9, 10, 11. We have 11 students not included in the list. 40 minus 11 is 29. All right. Now we get to some terminology that sometimes throws people off, and this is where we talk about at least, at most, and inclusive. And we sometimes use phrases to describe these scenarios, and those phrases are usually at least, at most, and inclusive. So if we wanted to consider randomly selecting a housing unit in the United States, the event that the housing unit has at most 4 rooms means that it has 4 rooms or fewer. The event that the housing unit has at least 2 rooms means that it has 2 rooms or more. And the event that the housing unit selected has between 3 and 5 rooms inclusive, it means that it has at least 3 rooms but has no more, or at most 5 rooms. So it could be 3, 4, or 5. So you just have to get used to those phrases. And you've seen these before in just some of your more regular math classes. If you talk about at least X, it just simply means greater than or equal to X. The phrase at most is less than or equal to. The phrase between X and Y inclusive, it means greater than or equal to X, but less than or equal to Y. So we're using the same mathematical symbols. We're introducing some terminology for statistics, though, that represents, or that can be represented by those symbols. 2 or more events are mutually exclusive if no 2 of them have any outcomes in common. So that kind of refers back to where I kind of went off a little bit on Part D in that last example, where it could have been B and C. There's no way a student can be in his 30s but also in their 20s. So that would be a mutually exclusive event. And in terms of Venn diagrams, you can see that here on the left. You have event A and event B. There's no shared outcome between them. Whereas in the second diagram, there's that overlapped middle. Those share those outcomes specifically with one another. So let's go back to the deck of cards, and we're looking at some events again. And in this case, the events that we're looking at, we want to determine whether or not the events are mutually exclusive. We're not determining outcomes, we're just determining whether or not they are mutually exclusive, which means they have nothing in common. The 5 events we're looking at is C, that it's a heart; D, it's a face card; E, it's an ace; F, it's an 8; and G, that it's a 10 or a jack. For part A, we're looking at C and D. So the event that the card is a heart and it's an ace. Or sorry, C and D. I looked at C and E. C and D. So the event that it's a heart and the event that it's a face card. We do have face cards that are hearts. So that is not a mutually exclusive event. For part B, so let's cross that one off. For part B, it's C and E. So that's the event that the card is a heart and that the card is an ace. We do have an ace of hearts in a deck of cards. So that event can occur simultaneously. So that is not mutually exclusive. For part C, it's D and E. D and E, the event that the card is a face card and the event that the card is an ace. No face cards can be aces, and no aces are face cards. So this is a situation where we do have a mutually exclusive event. So events D and E would be mutually exclusive. For part D, we have D, E, and F. The event that the card is a face card, the event that it's an ace, and the event that it's an 8. None of those can happen at the same time because you can't have a card that's an ace and an 8 and a face card at the same time. So again, we have another set of mutually exclusive events. They all exist independent of one another. For part E, it's D, E, F, and G. Well, we can go ahead and say that is a, D, E, F, and G are not mutually exclusive because we already know that D, E, and F are mutually exclusive. I'm sorry if I said that they are not mutually exclusive. I meant to say that they are mutually exclusive because we have D, E, and F already to be mutually exclusive, and then we throw in that it could be a jack. The problem is none of these cards can be an 8, so this also is mutually exclusive. And that's it. We're done. So there are your homework problems. There are 3, 4, 5, 6 questions. You'll have a week to complete them along with the homework problems from 112. If you have questions, you know how to get a hold of me, and I hope everybody has a wonderful day.